So today I'll be doing the chapter 2 review for chemistry. So chapter 2 is all about atoms and elements, and we know that an element is a substance that is composed of one singular atom, and an atom is the smallest part of an element, and each atom has a different structure. Also, we know that there's electrons, protons, and neutrons present as well. An electron has a negative charge, and a proton has a positive charge. And neutrons have a zero charge because the electrons and protons neutralize. We also know that a nucleus is a small, dense, positively charged that's in the center of an atom, and electrons are located on the outside of the nucleus. So usually we'd have like a ring here, and the electrons are around it. And we know that the atomic number is usually, it's going to be like 1, 2, 3, it can go 45, 55, and then the atomic mass is usually in decimal format as well. And you can usually round the atomic mass depending on what the number is. And we know that isotopes have the same number of protons but a different number of neutrons. So an example of that would be if I have a molecule with 5 protons and 7 neutrons, and another one with 5 protons and 8 neutrons. So moving on, we also worked on predicting mass of an element. So that's by converting the percentage to a decimal, then multiplying that, and then adding the masses together. And then we know that when you're adding electrons, that's a cation, and removing electrons are an anion. Yes. And then if we were to increase the number of protons, that would create a new element, and adding neutrons changes the mass of an element. And also when you are trying to find like the molecular format for a compound, or the chemical formula for a compound, you would take, like, let's say you're doing potassium and oxygen. You take K, which has +1, and oxygen, which has -2, and you swap their charges. So then the formula would be K2O. So that's something I was kind of easy, like wasn't too hard for me. That's something I actually was like good at doing. And we also talked about Dalton's atomic theory, and we know that all matter consists of tiny particles, and atoms come in whole number ratios. Atoms cannot be created, destroyed, or divided. Atoms come in particular elements with identical properties, and different elements have different properties as well. And we know that cations have positive charges and anions have negative charges. And the Catherpole-Ray device is what was used to discover electrons. And then the discovery of protons was the Goldstein, and that they had the same size charge but opposite in sign. And we also know that the nucleus was through Rutherford's gold foil experiment, and he realized that most of the atom has empty space, and majority of the mass is located in a small and dense region. And then we talked about modern atomic theory, and that's saying that the law of mass of conservation is that like the mass of the reaction is equal to the mass of the product. So if we had like firewood and we break that down into the components of firewood, it would still equal the same. But the law of depth and proportions is that all samples, no matter where it came from, has the same proportions of elements. And the law of proportions is that 2 elements from 2 different compounds have a whole number ratio mass to them. And we also talked about atomic size, and the atomic size depends on the atomic radius, and that is the radius is the distance from the center of the nucleus and the outermost electron, which will give us the radius. And then if the atomic group is like this, like top to bottom, it increases, from left to right, it decreases. And we know that Avogadro's number is 6.022 times 10 to the 23rd power, and that's equal to 1 mole. And AMU is replaced by grams, and it is called 1 mole as well. And then when you're naming elements, we're trying to figure out the largest element, you would first go by the like the number of cells first, And then once you go by that, you go by the rows. So top to bottom first, then left to right to figure it out. And then we also talked about calculating mass and how to calculate mass. For mass to moles, you'd have to take the given mass divided by the molar mass and gives you the moles. And for moles to molecules would be whatever the moles is times 6.022 times 10 to the 23rd. And that would give you your mass. And that was all for chapter 2.